Hi again. Welcome to the video on log laws, in which we address the ways we can manipulate these important terms to help us in our analyses. The laws need to be understood so they can be applied in many contexts during your course. Hang on, we're going for a ride. In previous videos we've established the definition of a logarithm, and we've also been able to understand the relationship between the logarithmic function and the exponential function. So now we're bringing those two things together to investigate ways we can manipulate the logarithms. There are 6 fundamental strategies, and these are commonly referred to as the log laws. For law 1, we know that a can be rewritten as a to the 1. So using our transformations to logs, we can write log a to the base a is equal to 1. Now the base a can be any rational number, so taking the log of a number equal to its base, its value is always going to be 1. So if we have log 2 to the base 2, that's 1. Log 42 to the base 42, that's 1. Log of j, good number, good letter, log of j to the base j is equal to 1, so good. Log of u to the base u is equal to 1. And log of us to all of us is 1. To start law 2, we know that 1 is equal to a to the 0. So again, using our transformation to logs, we can write log 1 to the base a is equal to 0. Again, base a can be any rational number, so taking the log of 1 to any base, its value is always 0. So log 1 to the base 10 is 0. Log 1 to the base 42 is 0. Log 1 to the base e is always 0. For law 3, we're going to let x is equal to a to the m, and we're going to let y is equal to a to the n. Converting these two to log format, we obtain log x to the base a is equal to m, and log y to the base a is equal to n. Now we add those two together and we have m plus n, and that's going to equal log x to the base a plus log y to the base a. Multiplying our two basic terms together, we can have x times y right up the top, and that's going to equal a to the m times a to the n. Using our index laws, that's equal to a to the m plus n. Now converting that equation to log format, we obtain log of xy to the base a is equal to m plus n. So we now have two terms in m plus n, and so we can equate them, and we end up with our law, which says log of x times y to the base a is equal to log x to the base a plus log y to the base a. So I'll rewrite that law on the top of the this page, because your screen's not quite big enough to have the rest. So we have log 6. Now 6 is equal to 2 times 3. So we've got an xy term here. And then the law says we can split that term up to say log 2 plus log 3. Log 42 is equal to log 6 times 7, so we can write log 6 plus log 7, or we could have said 21 times 2, which means that we could have written log 21 plus log 2, etc. If we have now some algebra, log of x minus 1 times x plus 3, we can rewrite that as log of the first one, x minus 1, plus log of the second one, x plus 3. This rule is saying that the logarithm of the product of two numbers is equal to the sum of the logs of those two numbers to the same base. It's a very important law, and it's going to be used very frequently. The fourth law follows very much from the third law. It states that log of x divided by y is equal to log of x minus log of y, again with the same basis being used. So here we're saying the log of the division of two numbers equals the difference between the logs of those same two numbers with the same base. I will leave you to prove that. Examples: log of 12, which we could have written as 24 over 2, is equal to log of 24 minus log 2. If we have log 42, then of course that's 126 over 3. So log of 126 over 3 is equal to the difference between the logs of those numbers, log of 126 minus log 3. If we have a more complicated situation, we've got log of AB over C. So we'll take the division first, and we can have log AB minus log C. But from the previous law, we know that log AB can be written as log A plus log B. So our result is log A plus log B minus log C. The fifth law also follows from the third law. We note that log of x squared can be written as log of x times x. But by the third law, we can split the multiplication into the sum of two logarithms. So log of x squared, or x times x, can be written as log x plus log x, which is 2 log x. Similarly, log of x cubed could be written as log of x times x, which is log x plus log x plus log x equals 3 log x. So generalising this result, we can state that if we have log x to any base raised to the power n, then that is equal to n log x. The n just comes down the front. So log of 5 squared is equal to 2 log 5. Log of 36, which is log of 6 squared to the base 6, equals 2 log 6 to the base 6. Log 6 to the base 6 is 1, so it simplifies to 2. For our sixth and last log law, we're going to let log of n to the base a is equal to y. So unpacking that into the exponential form, we have n is equal to a to the y. Now we write log b in log to the base b in front of both of those sides. So we have log n to the base b equals log of a to the y to the base b. And that last term can be rewritten by bringing the y down the front. So it's y log a to the base b. Now dividing gives us y is equal to log of n to the base b divided by log of a to the base b, where b is any required base that we want. This result provides a format for us with which to change the base of a logarithm, and that's especially important when we make a statement to a base other than e in particular. Therefore, log x to the base 5 can be rewritten as log x to the base e over log 5 to the base e if we want e to be the base, or we could write log x to the base 10 over log 5 to the base 10 if we wanted 10 to be the base. So in summary, log a to the base a, which is any number to its own base, is equal to 1, always. Log of 1 to any base is equal to 0. If we have a product, log xy, then that's equal to the sum of the logs, log x plus log y. And that's what you say to yourself, the log of a product is equal to the sum of the individual logs. If we have a division, x over y, then the log of that quotient is equal to the difference of the individual logs. If we have an index in there, so it's log x to the n, then we just bring the index down, so it's n log x. So we're going to use that log law for creating an index from a coefficient and vice versa. And then the last log law was our change of base relationship, where log x to the base y was equal to log x to another base over log y to another base. So we could use that very easily. You now have a summary of the basic log laws, all of which we use frequently. You have to be good at using them. To develop your expertise, go to both the next video showing examples of their application, or try some of the test yourself questions on my website at drjsmath.com. You pick the order best for you. Hit the like button and subscribe if you haven't already. Good luck. See you in the application shortly.